This session's topic is familiarization with Arduino, and to talk a bit about the Minibot kit. First of all, my apology for not having got all the 3D printed parts done. So I don't have the society printer with me, and someone's mic is on. Would you mind just checking your mic so we don't there's some background noise? Cool, thanks. Because I don't have the society printer with me, and it's another society member doing it, and apparently there were some failures with 3D print, and they usually take more time, so it was not that perfectly planned. So there were some 3D printed parts that were not done yet, and also I think when I checked the components, some of the kits don't have all the components listed, and that is when I checked it myself. So if you find any missing components, please do raise it to me either by Slack or email. This is what the kit should have: the chassis, a couple of components, and you can find the link to the component checklist through this link. Sorry, the form for the checklist through this link. A bit about the Minibot kit. So upon receiving the kit, please check that if there's anything missing, obviously, and whether components are working as you start working. Because some of the components are recycled from last year, and some of them are new, but I haven't checked all of them myself. So in case they are not working, it's probably not your fault. So we'll see how it works and see if we can get a replacement for you. And it is recommended that you don't strip all the jumper wires like this. So I'm putting it to the camera. Those jumper wires are bounded together, and you don't want to strip all of them into a single wire, because the grouped wires may help keep your circuit tidy. So in case you are tempted, please just restrain yourself from doing it. If you want to try soldering yourself, make sure you know how it works. So I basically given you a choice. The light sensor in particular, all of it are new, and they come with the pins and the sensor. So if you know how to solder, or you want to, or if you're feeling ambitious, you can do it easily in the Dyson Center. There's a soldering station, but just to say that in case you get the soldering wrong, you might cause a short circuit between the pins and may make it just not usable. If you are worried about failing, I can always do it for you. But I just want to give you the choice. And always unplug batteries when you're not working, because the battery case holding 4 batteries, if you leave the cable dangling, you might cause a short circuit and burn the battery. So always unplug them and remove them from the battery case when you're not working with them. And finally, just want to let you know that the winning team of each year gets to keep their robot, and we would like to collect all the electrical components at the end of the project from the other teams. So it's fine if you break a few components, because that's only normal when you're trying robotics, but please try not to break them carelessly. Yeah, that's what I'll say. We talk about the Arduino being an open source electronic component, and we don't need to worry about all this mess. The key thing working, I believe, is this thing, which is the microcontroller chip, and all the others are for dealing with how to make the pins connect to the chip and to deal with all the peripherals, power supply, stuff like that. So I got this from Wiki. A microcontroller, MCU, is a small computer or a single metal oxide semiconductor integrated circuit chip, and a microcontroller contains one or more CPUs along with memory and programmable input-output peripherals. So this is the main thing that's working. It might be slightly different for yours, because I believe this is Arduino Uno R3, and the ones we are using, I think, is not the R3 one. So it's the one we have is this chip in the middle that's doing the job. and the clock speed is 16 megahertz, and your normal PC are in the range of gigahertz, so it's not as near as powerful as a computer, but still it's a very small device, and most of the job you're doing doesn't need that many computing power anyway, so it's fine. And it can be powered via the USB cable or battery through the barrel jack. So you power it with a 9-volt battery through this one, and you use the USB Type B cable on this power jack. Cool. Let's talk a bit about what those pins are. So first of all, there are, I believe, 19 input-output pins in total. And if you have a close look at the Arduino, if you have it with you, those 6 are named A0 to A5, and they are the analog input pins. So if you want an analog signal, which is like, because Arduino work in the range of 0 to 5 volts, so analog signals would be 0 to 5 volts, say, for example, 1.5 volts, 3.3 volts, stuff like that. And you want it to read it, you put it here, you connect it to those pins. And if you want digital inputs, which is basically 1 or 0 or 1, low or high, or 0 volts or 5 volts, you use it here, the digital pins. And so the reason that you get analog pins is because to read an analog signal, you need ADC converters, which are analog to digital converter. They basically digitize the signal. So for example, Arduino, if you want to read an analog signal, they use 10 bits for it. So say 2.5 volts would be converted to, so 2 to the power of 10 is 1024. 2.5 volts would probably be 512, 2 to the power of 9, for example. And for digital ones, oh, by the way, those are inputs. And for outputs, normally you can only have low or high outputs, 0 or 5 volts. But there are some special PWM pins that serve as analog outputs, and they are marked with the curly signs. They can output analog-like signals. And those are some of the general pins. For example, there's the power, 5 volts power, 2 grounds. And this V-in is used if you want to supply an external supply through this pin. So for example, if you want to choose not to use the 9 volts battery as a power supply, you can use your AA battery by plugging it through the V-in, but we are using that for the motor driver, so there's no need to do that. And some other pins here are like SCL, SDA, they are related to I2 squared, not I2 squared, I squared C, sorry. And that's a communication protocol, and some of the devices, some of the sensors we're using are going to have to use that. Yeah, that's a general idea of those pins, and there are some inbuilt LEDs, stuff like that. Cool. Next, let's talk about breadboard. So there's nothing special about breadboard. You can think of them as female to female wires. So the wires we've given you, there's only male to male or male to female, because you got a breadboard, which is basically you just insert all of those male ends onto the breadboard, and they serve as female to female connectors. So for example, if you plug a pin here and a pin here, they will be like connected, because this is essentially on this power rail, it's all connected. And if you look at one of the breadboard, they will actually, in the power rails, it's actually not marked like that. It's usually plus, minus, minus, plus. They don't have any actual meaning, but it is recommended that you plug, say, 5 volts on this line and 0 volts or ground on this line. So it will just make your circuit more tidy. And yeah, and for those in the middle, they go like that. It's just to ensure that you can plug all your components with less, instead of only using those wires, which would make it really messy. And yeah, it will be very easy to get them wrong. And so when you want to put a chip, for example, like the motor driver, you just put it across the middle bit and put all the pins along like those lines, so they're all separated and you can wire them to other places easily. And a good practice is to color code your wire. So the most obvious thing to do is that you use red for power and black for ground, and you use the other colored wires for to mean different signals, either input or output. And yeah. Okay, so we didn't explain how we achieve the analog signal output just now, and this slide will explain how you actually output an analog-like signal. So actually, the Arduino can't really output like 2.5 volts, but what it can do is it does this PWM thing, which is pulse width modulation. It's like the signal that you send out. It does like high and low in a set cycle, which happens very fast, and it is kind of equivalent. If it's 25% of the time it's high, it will give a result of a signal which is like averaged here, and that is kind of like an analog signal for the components. The components will kind of see an analog signal. And for example, in motor drivers, when you want to let the motor run at full speed, you will give it a 100% duty cycle, which is just a high signal all the way around. And if you only want to give it 75% of the power, you will use a PWM to output an analog signal that is 75% of the full power. So if you label the y-axis, it's gonna be like 5 volts here and 0 volts here, basically. Great. Now let's move on to how you code and how you connect the wires for ultrasonic sensor. Ultrasonic sensor, as we mentioned last time, is used for measuring distances. There are 4 pins, VCC, ground, and those are power pins. You always connect the VCC to 5 volts. Usually it's 5 volts. There are some components that use 3.3 volts, and you always connect ground to the Arduino ground. And those 2 pins are used as one of them is input and one of them is output. The input will send out ultrasonic pulse when the trigger pin is pulsed, and the echo pin will note when the reflection is received. So using this time and the speed of sound in air, it converts this to distance. And there is a library that does all of this, so you don't need to write, say, let the trigger pin output some pulses and let the echo pin, like when what the input you get for the echo pin, you calculate the distance or something, because the library just handles all of it. Yeah. And this is the code you use. So yeah, I forgot to mention that usually you use the Arduino IDE for coding in Arduino, and the language is very similar to C++, and it uses a compiler as well. So that's the main difference of the say C++ or this the language that Arduino uses to Python, is that it needs to be compiled before you run it on the on your Arduino, and I'll do a demonstration of it later, how to use the IDE. And so I'll go through a bit of detail into the code. The first line include is basically to import a library. So HCSR04, it's a library for using the ultrasonic sensor. The .h basically means a header file, and it's just a C++ thing. And you define the ping. So when you're writing the code, it's more clear. You don't write things like A0 or A1. And whenever you want to change the ping to use, it's much easier to just change it here instead of changing all of those variables in the code. And the first line, ultrasonic sensor, ultrasonic distance sensor, it's basically the class name, I believe. So I'm not that familiar with C++, so if you spot anything wrong, like feel free to just put it in the group chat, because like I might be wrong. So that is basically creating a new instance of the class, and that class is from this library. And the inputs are trigger ping and echo ping, which you define here. And for Arduino code, there's usually two main functions: the void setup and void. Okay, it's not void setup; it's actually setup. And void basically tells you what data type it returns. Returning void means that it doesn't return any data type, because we are not like returning anything here. And the loop function runs over and over again after you run the setup once. So serial begin has to do with communication. It's basically to do with like when you open the console, it will display the results that you printed. Let's see. So, and by the way, the other difference between languages like C++ and Python is that you need to define your variable, the type of your variables explicitly. So for example, here, in the loop, you define a floating variable called centimeters, and you invoke the method of test sensor, which is the object you defined here. And you invoke its function, which is called measure distance in centimeters, and it will return the result and print it on the console. Delay 1000, I think it's an Arduino thing. It basically means to pause for 1000 milliseconds, which is 1 second, and the loop will, and then we will step through the next instance of the loop. So basically printing out the distance every 1 second. Yeah, I think I'll actually demonstrate them later if we got time. Servos are small motors that have their positions accurately controlled. So it's not 100% accurate. I think a better description would be a motor with feedback, because it's got some encoder circuit, I believe, inside that tells the motor to stop when it reaches the given angle, and when you try moving it while it's powered, it will resist your movement. But there is a maximum torque that it can produce. So if you try really hard, you can just break the servo easily. Or if the servo is stuck somehow, it will just be constantly applying the current, and it will may cause your servo to heat up. So do be careful. If you find your servo heating up, it's probably because it's stuck. And the position is controlled by the PWM value, which is basically like the analog input you give to the servo. And it has a limited range of movement up to 270 degrees. Though when I test it, usually it's just like up to like 0 to 180 degrees. So they're not very powerful, and they can be quite delicate. And I'm not sure about this line either, because usually I just connect it to the Arduino 5 volts ground, and that is fine because it doesn't draw a lot of current, and the microcontroller can just supply it. I mean the Arduino. And there are 3 different color of wires here. Red and brown are power, and yellow is the PWM signal you input. Next are the IR line following sensors. The IR sensor module measures the amount of light reflected back, and there's a threshold to determine whether it will give 0 or 1. Because as I said in last session, that they return Boolean results, which is either true or false, and therefore there's just a threshold defined arbitrarily by the circuit. But as we are using it to recognize the tape region or non-tape region, so it should be very clear. And there are 3 pins here. Actually, I think I got one of these with me. I'll try to find my. Yeah, here we go. So I'm not sure if you can see the text on the pins. So there's a VCC, a ground, and a output pin. And it will start working as soon as you give it power supply, which is the VCC and ground. And if you connect the out to one of the pins in Arduino and you set that pin to input, you can start collecting data from the IR sensor. Here are some tips. So whenever you are working with the sensors, the components, make sure to color code your wiring. A good start is red for power, black for ground, and use different color for the different pins. And make sure all the components share a common ground. Whenever you're not using the kit, please do unplug the 9 volts and 8 batteries. And you should test all the components individually before you start assembling the whole robot, because it will be really hard to go through all the mess of wire to like check one component when you finish assembling the robot. And whenever you got anything that you're not sure about, like Google often just have all the answers there. And all the components, I believe I've given the full name. So if you just type the name of the component onto Google, you'll see a lot of, you can find the data sheet for it. And there'll definitely be people before you asking questions about it. So yeah, and you can ask supervisors if you're not sure. I've already confirmed the supervisors for this year's Minibot, and we'll send out like the form, which supervisor for which group soon. And some action points. So for this week, please have one of your team member, at least one team member, to install the Arduino IDE. And after that, you can start testing components that we went through today. And if they are not working properly, just let us know, because as I've said, some of the components are recycled from last year. They were working when the previous groups use it, but no one knows when they would just go wrong. And please go through the checklist to see if anything is missing. And it would be good if you can agree on good working schedule that works for everyone. And finally, another thing is that in case, because it's already it's the 3rd week. Yeah, it's the last day of the 3rd week, and I know that a lot of you might have like multiple commitments, and in case anyone in the team probably decides to pull out, I think there are still a few members who are keen to join in, but not in this project. So, so if you are like the team lead, do let me know if you think there's a shortage of person. And I think that's it for today, but I'll also proceed on to do some demonstration. It will also be recorded, but if you already worked with these things before, or if you want to say figure out how to do it yourself, I think that's it for you today. So this is the Arduino page, and you go to the documentation. Reference, and those are the common functions. There are in Arduino, and you can also download the software here for free. So after you finish downloading the IDE, it will look something like this, right? Yeah, so I got my Arduino connected right now. I'm not sure, the wire is a bit short, so I think you can kind of see it. I'll just upload this. This is one of the default code. So whenever you finish writing the code, you do upload. Make sure your Arduino is connected via the USB wire. And it will show that it's compiling right now. Okay, so now it's done. This blink code, I don't think you can see it, but one of the inbuilt LED is flashing right now. I've already used the ultrasonic code as an example, but this is also quite a good example, I think. So the setup. So if you want to try to understand what this does, this says pin mode, and we know that this is a function, and we go to the Arduino page to see what pin mode is. Click on it, and it tells us that the pin is the Arduino pin number. Set the mode off, and the mode is input, output, or input pull-up. You'll be mainly just using input and output, but feel free to see what this means. And back to the code. We set the LED building, which is the pin for the LED, and we set it to output because we want to give the signal to the LED. And then the next function is digital write. So if you want to, no, actually, this is just one of the pin. Like it's just same as say digital 2, digital pin 2, digital pin 3, just a special pin. So after you set the pin mode, you can do digital write, which means that you write a value to that pin. So when you write high, it means 5 volts to the LED, and then the LED will turn on. After 1 second, you write digital write low, and that means 0 volts, and the light turns off. So it looks as if it's flashing. And yeah, if you want to know what digital write is, also this is pin mode. You can write a high or low value to a digital pin. So we have just configured it with pin mode. So we set it to 5 volts or 0 volts. Just the function for digital write. So those will be similar functions for you to write to more complicated components, but the principle is all the same. Yeah, so even though this is a simple code, I think it covers quite a lot of what we do for the other components as well. Great, so let's move on to UR. No, actually, I think IR sensor is the best place to start. This is the IR line follower, and what we are doing here is that we define the pins first. So this line means that we define pin 3. So pin 3 means digital 3. If you look at the board, it's the one here. It's here. We define it as left IR. So you might think that in your code you are writing more characters, but it just makes the code clearer. So I would say it's a good practice, even though you can probably just remember that it's 3 and 4 for the 2 IR sensors you are using. But when you start putting everything together, this will make your code much more readable. And therefore, we define the pins at 3 and 4. And so pin mode, we are setting them as input. We are setting pin 3 and pin 4 as input. And we do the serial begin. This is just to begin the communication. And yeah, I'll just demonstrate what this code does real quick. Let me just, so this is a really bad practice as I'm using just 2 white wires and blue wire because that's what I have next to me at the moment. But you shouldn't do this when you do it yourself. Let's connect the output pin to 3. I'll just use 1 IR sensor. And we connect the VCC and ground to 5 volts and ground respectively. So this is the IR sensor fully connected. If I put my fingers here, the light will, there's an inbuilt LED that makes it much easier to test things out. I believe it's a reflective surface that works. Seems that my fingers are reflective enough. Yeah, so if I try something black, I don't think it will stop working. I think I'll use my phone. Seems like it's still reflective. Oh, I'll use the back of my phone. That's not reflective. My screen is reflective. So if I cover the transistor with that, it won't work. But it's a white surface, it will work. And let's show it. Yeah, I should show it in this monitor as well. Let me just upload the code. So I haven't uploaded the code yet. As I've said, when you connect, as soon as you connect the sensor to power supply, it will start working. But you need to upload this code for it to actually make use of that data. It's working right now. I believe it's working right now. So I think this is the left sensor we are looking at. We are looking at pin 3, which is the left sensor. The right sensor is always 0 because nothing is really connected. So I think that's just the default value. Let's just look at the left sensor. Yeah, just look at the last line showing the console. So if I put a white reflective surface, you can see the LED is flashing. And if you look at my screen, it should be showing 0. Yeah, it's working. So you can show that when I put my a surface there, it just turns the left to 0. And one thing to take away is that this serial.print is a very powerful function that you should use quite often for debugging and to see what input you actually get from your components. So yeah, that is one of your most powerful tools. And I believe it's in communication, serial, yeah, functions, print long. It's just something to do with the format. Cool. So IR sensor, I think they're pretty trivial. Next, let's move on to ultrasonic sensor. Oh, I need to get more wires for this. Let me just get white box. So first line, I think I've explained this code already. I'm using 6 and 7 for the trigger ping and echo ping. And let me just connect them. Oh, this is you know what? I'll actually use this. Like there are, I think, 40 wires here or 20. There's like 30 wires here, but I can just use 4 of them. Yeah, so just back to the point, if you are sure you are using this 4 wires, you can then strip it from the group. But before you are sure of that, don't just strip everything, because if it's grouped like that, it's really handy. It will be really neat when you try to put it. So that's connected to 6 and 7, trigger to 6. And that's the power supply. It's to 5 volts. By the way, because all the components are using VCC 5 volts, you should connect the 5 volts and ground to the power rail on the breadboard, and they're all like parallel 5 volt supplies. Great, so let's test it now. Bring on the serial monitor. So -1 is for when it cannot detect the surface, and I plug it into the Arduino that's not connected to the power supply. Sorry, guys. That's white. Hopefully this should work. Let me just reload the code. Oh, port busy. Never saw this problem before. Great. I did it. There's probably something wrong with the connection from my Arduino to my computer. Okay. This is really bad. Don't do this. Like, I mean, a whole group of 5. So hopefully, if you focus on the newest, the most recent results, you can see that as I move the paper away from the ultrasonic sensor, you can see the numbers rising. So I hope that I've convinced you that it works. And if it's not working, if it's not taking results properly, for example, when I connect it to the other Arduino, which is not connected to the power, it will just be showing -1. And otherwise, I think there's a range limit. Oh, I never knew that my room is like 4 meters in this way. I think there's a range limit as well, and it will show -1 if it exceeds that limit. But basically, yeah, do feel free to try it yourself. And it's good at detecting surfaces. It's not that good at detecting an object, because as you know, waves can just move past an object, and just play around with it. We are going to use the ultrasonic sensor for detecting the opponent robot, and definitely do some trials to see how well it can perform at determining a distant object. Yeah. So next, let's move on to the last one, which is the servo. The servo, like similar to ultrasonic sensor, uses a library as well called the servo, and basically, it's not. Yeah, you either put 5 or you put the servo pin here. I didn't bother defining the pin here, and you use the function right to change the angle of the servo. Let's see if I got one. So you need a power supply for the servo. You can use the 5 volts. And you need a PWM pin to control. So the library does it for you. There will be a digital write in the library somewhere that controls the PWM input, but you can just use the function because it's much easier. And we are using pin 5. And when you choose the function to attach your servo to, the pin to attach your servo to, you have to choose a PWM pin, because otherwise it just won't work. And servo looks like that. Doesn't have a servo point yet. Great, so that's one of the servo home. You are using the servo home that I gave you is different because that one fits into the Reaper part that I designed. But the principles are the same. This is the reason I'm putting the home on is just to show that it's moving to the angle I want it to move to. So once again, you change it to 90 degrees, and then in the loop, you do 0 degrees, delay by half a second, and then 180 degrees, move to delay by half a second. So let's try it out. So hopefully you are convinced that, oh, let's do this. So that is just to make sure that it stops at 180 degrees, and because it's moving too fast at the moment. Okay, so it moved to 180 degree. If you try moving it, unless you try really hard, like you can't really move it. How do I show this? So if you put a weight here, as long as it does not exceed the maximum torque, the torque that it can produce, it will stay like this. Yeah, so that's servo. And I think that's it. There are some components. There are still some other components I haven't covered in this session. We are going to do it for next session. But if you want to try to figure out how it works yourself, as you have the kit already, feel free to do so. And I think I'll probably be present in the Dyson Center Friday afternoon, probably 2 to 4 or 2 to 5. And if you have any questions, or if you think any of the components are not working, you can just bring it with you, and I'll see if there's anything we can do for it, or if I can give you another component. Because I feel like you might have quite a few questions up till this point, but you just probably just don't want to share it like in a session that's recorded. So fully understandable. But if you do have any question, feel free to like come to me like then,